Hi there. In this video, we're going to take another look at domain and range. Domain and range is one of those topics that once you get it, it's great. But before that, a lot of students struggle for a little while with exactly how it works. So just a reminder, domain is the set of all possible x values of a function, and range is the set of all possible y values of a function. And here it's shown like this. On this function, we can see all the possible x values are from here to here. So that would be our domain, x values from here to here. And our range, all the y values. So here's the lowest y value possible, here's the highest. So the range would be all those y values from this bottom one to this upper one here. Okay, with this exercise, we're going to look at 6 different functions, and I want you to use Desmos. So please open up Desmos on your computer and prepare yourself to graph each of these functions. As you graph each one, look at the graph that Desmos shows you, and then give the domain and range for that based on the graph you see. So let's try the first one. Graph it, and then state the domain and range. Okay, here's what your graph should look like. Of course, you might be zoomed in a different way, but basically it is a line. We can see here, it's clearly linear. This is a linear function. It goes forever in both directions. And that's the key here. A line goes forever in both directions. So eventually it will cover all x values and all y values. So therefore, the domain for this one can be written like this. I'm going to show in this presentation all 4 ways that we've talked about. There's set notation, and then another way to look at set, which I'll talk again in just a second. So set notation and also interval notation. And we learned for interval, there's 2 ways. There's one way where you use only squared brackets, and there's another way where you use round brackets combined with square brackets. So let me explain all these here, and then from here on, we'll go a little bit quicker. So first of all, domain. In set notation, we always use the curly brackets for set. So domain is the set of all x values such that, so it means all x values except for there's this condition on the x values. So the x values must be values between negative infinity and positive infinity. And well, that means x can be any value, right? It goes from negative infinity to positive. It can be any number across the real number set, right? Another way to write that, since we're saying from negative infinity to positive infinity, we can just write it like this. We can say the set of all x values such that x values, or x is an element of x is an element, that's what this symbol means, element of R, which is the letter we use to represent the real number set. So x is any number in the real number set. And real numbers mean any number, any positive, negative, any fraction, decimal, anything, right? Any number we know is a real number. So that's the same meaning as this. These two mean the same thing. Okay, now back to interval notation. When we say from, interval notation means from some number, comma means to some other number. So here we say from negative infinity to positive infinity. And the reason I use these outward turned square brackets is because what that means when the brackets turned out like that means it does not include that value and it does not include that value. We cannot include infinity because it's not a number. So when we say from negative infinity to positive infinity, we cannot include it, so we have brackets like that. Another way to write interval notation is to use round brackets when we do not include a number. So this here means the same thing as this, negative infinity to positive infinity, but we say round brackets because we're not including that negative infinity and we're not including the positive infinity. Okay, let's talk about the range. Well, for this one, yeah, very easily the range is the same thing because the range, just like the x values, the y values for a line are all possible y values. So everything is identical to here. Okay, let's look at the next one, b. So graph this one. This is called a root function, and see what it looks like on Desmos, and then see if you can define the domain and range for it. Okay, here's the graph. Every root function has this shape. An interesting way to remember what a root function looks like, this square root function, is that it looks kind of like the letter R for root. Okay, so it looks like that. Notice it begins right here. So the domain is this. X values such that x values are from 0 to infinity, because the x values begin here, and notice I have including equal to, x can be 0, and all the way to infinity, because this also goes forever. So from 0 to infinity, including 0. But not including infinity, right? Because we cannot include it because it's not a real number. Okay, and finally, and written in another way, is like this. Rather than writing from 0 to infinity, we can just say x values can be any values of x greater than or equal to 0, because that means the same thing as going to infinity, right? So greater than or equal to 0. Okay, in interval notation, so x values can be from 0 to infinity. including 0. So now notice the square bracket is turned inwards. So from 0, including 0, to infinity, not including infinity. And likewise, if we use the other type of interval notation where we don't use the outwards turned square bracket, we have from 0 including to infinity, and then rounded means not including. So that rounded bracket and that outwards turned bracket mean the same thing. Okay, what's the range of this one? Well, the range for this one is, again, just like the domain, because the root function begins right here. Therefore, y values can be from 0 all the way up forever. So from 0 to infinity. And, well, that's a mistake. This should have equal to. Let me change that. Again, if we say 0 to infinity, we can also just say y values that are greater than or equal to 0. And then interval notation matches what we had here for the same reasons. Let's look at C. Okay, C. Put that in Desmos and see what you get. Give the domain and range. Okay, here it is. It's a line. And you may be thinking, wait a minute, that doesn't look like a line. X over 4 looks like a fractional function. Why is that a line? Well, another way to think of this one is f of x equals 1/4 times x. That's the same thing as this. If you multiply this fraction by this x, that x ends up on top of that fraction just like that. And that's clearly linear. Our slope is 1/4. And there's no y-intercept because there's plus 0 here, which means a y-intercept of 0 and then a slope of 1/4. So notice, look, it goes up 1 over 4 to get to the next point. So that's linear for sure. And just like the last linear one, we have a domain and range that are easy to see. It's all values, negative infinity to positive infinity, or x is an element of the real numbers. We talked about that. Or again, all this is the same to the first one we looked at. So take a moment to look, and let's go on to the next one. Okay, next one looks like this. Well, this one's a little different than that. Okay, this is now 4 over x. That's different. So graph it, and let's see, what's the domain and range? So here's our graph. What we've graphed now is called a rational function. When we have a fraction here, which has variables in the denominator, we call that a rational function. And rational functions typically take on this shape. There's one curve here, one curve here. And in between those curves, there's something that is called an asymptote. We haven't talked much about it, but it's never too early to start looking at what asymptotes are. There's an asymptote right there. An asymptote is like an invisible line, and basically the function from one side approaches that line, and forever it will be getting closer to that line. It's like a wall, but never reaching it, never touching it. And likewise, from the other side, this curve will be approaching this invisible line, getting closer, 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 but never getting to it. That's what an asymptote is. There's also another asymptote here. Another asymptote is here. So just like these graphs here approach this invisible line, they also approach when you go to infinity here, they approach that, and this one when it goes to positive infinity also approaches this invisible line. These invisible lines are part of what this function has as its components. So those are called asymptotes. And now those help us define what the domain and range are. So imagine if the x values, this curve goes forever in that direction and forever in this direction. So the x values can be anything all the way to negative infinity, anything all the way to positive infinity, except for x values cannot be here, because I just said that these curves will never reach this asymptote. They never get to it. They get closer and closer forever but never reach it. So check out what the domain is. The domain is a set of x values such that x can be an element of the real numbers. That means x can be any value except, comma, x does not equal 0. So x can be any value except for 0, because this function will never get to this 0 line. So it will forever be closer but never reach it. So 0 is the one exception. That's where the function does not exist. All right, we can write that in interval notation like this. Okay, we have negative infinity to 0. So imagine the x values. We have negative infinity to 0. Those are all possible x values. And then we have a hole in the graph. So we pause, and then 0 to infinity. So negative infinity to 0, and then 0 to positive infinity. But we have a break. And we show that there's two parts to the domain using this symbol here. So x values can be any of those numbers, and this means union. So that means or x values can be any of these values. And notice how this bracket is turned out. That means you do not include 0 here, and 0 is not included here either. So that means 0 is that one exception, just like we see here. And written in the other type of interval notation looks like this. Negative infinity to 0, rounded bracket, means the same as outwards turned square bracket, means it does not include that value. And then union, so x values can be these or these values, 0 to infinity. Okay, and hopefully looking at that, you're thinking, okay, the range is the same thing. It is, because there's an asymptote at y equals 0 also. So y values can be any real numbers except y cannot be 0, for the same reason as we saw here. And then this all mirrors this exactly. It's the same. Okay, let's try this one. Put this in Desmos, see what the graph looks like, and let's get the domain and range. This graph looks like this. Again, it's a fraction with variable in the denominator, so it's going to be what's called rational again, just like this one was. And rational again always has this shape, curve, curve. Now where's the asymptotes in this one? Well, try to imagine where that invisible wall is in the middle, that where these will get closer to it but never reach it. Where is that kind of middle line between those two curves? Hopefully you're thinking right there at x equals 4. And we also know that because look at the denominator of the fraction. What would happen if x was 4? So imagine putting a value of 4 in here. So if you put 4 in there, you would have 4 minus 4, which is 0. And we would have 4 divided by 0. We know that we cannot divide by 0. That's an undefined concept in mathematics. So that means that's exactly what's happening here. We see if x was 4, this would produce a situation that's impossible. Therefore, this graph is impossible at x equals 4. And that's why the asymptote exists there. All right, and the other asymptote is still here at y equals 0. So what's our domain this time? Well, the domain is x can be any real number. So x, again, the function exists everywhere, except the function doesn't exist where this hole is at x equals 4. So last time the hole was at x equals 0. Now it's at x equals 4. So x can be any real number, except x cannot be 4. So that is the one exception. And we show it like this in interval notation. We go from negative infinity, not including it, to 4, not including 4, because that's a hole in the graph. And then union, so x values can be these values, or x values can be these values, 4 to infinity. So the ones from 4 up to positive infinity, not including 4 again. And like this is the other type of interval notation where the outwards turned square brackets are now rounded, which means the same thing. Okay, what about the range? Well, the range has not changed from before because the horizontal asymptote is still here, so therefore the range is as it was before. All possible real numbers except y cannot be 0. All right, we've made it to the last one, and this one should look familiar. That is definitely a parabola, quadratic. We studied a whole unit on that, so we should already have an idea of what that graph looks like. But put it in Desmos, and let's get the domain and range. So here's our graph. It's a parabola. And we know our domain is all numbers because these should have arrowheads at the end here. It means it goes forever in both directions. So eventually all x values will be covered by this function. So x values in the domain are any numbers from negative infinity to positive infinity. Oh, that's a mistake. That should not be equal to. Let me change. Okay, so here we are. X values from negative infinity to positive infinity, or x can be any real number. And in interval notation, it can be this or this. So from negative to positive infinity, not including each one, so outwards turned bracket, or rounded bracket means not including also. Okay, range. Range in this case, we see y values, the lowest possible y value is -1, and then the function goes up forever. So the highest possible y value is infinity. So we can see that here. The range, the set of y values, from -1 to infinity, including -1 because that point exists right there. So including it equal to, or you can just say y values greater than or equal to -1. Or in interval notation from -1 to infinity. And notice it includes -1, square bracket, and does not include infinity. And likewise using the other type of interval notation where we use round bracket instead of outward square, we write from -1 to infinity, not including infinity, but including -1. All right, so I hope that final look at domain and range, I think that's the last time we'll look at it, is helpful, and you're starting to get a better feel for these and understanding how to write it out properly using all the different notations.